All right, Algebra 2 fans, today we're looking at even and odd functions. Okay, so first of all, an even and odd functions. The definition of an even function is this: f of negative x is equal to f of x. Well, what does this mean? Well, remember, this right here, if I'm changing a positive x to a negative x or a negative x to a positive x, okay, if I'm changing those things, so an even function then is simply a reflection over the y-axis. Okay, so this is the definition, but an even function is literally a reflection over the y-axis. Okay, and then an odd function has this format: f of negative x is equal to negative f of x. Okay, and that is literally, if my, this is saying negative x, this is saying negative y. So what we're literally looking at then is a reflection in the origin. So reflection, origin. Okay. So even functions is literally, it's a reflection in a reflection over the y-axis, and then an odd function is a reflection in the origin. All right, so now let's look at some examples. So we're looking at this partial graph here. So our job is to sketch the other half of the graph if we're going to deal with an even function or if we're going to deal with an odd function. Okay? So what I'm going to do is I'm going to list the ordered pairs out. So, all right, well, it's right here. Here are your ordered pairs. So an even function is reflection over the y-axis. Remember, reflection over the y-axis literally is this: x comma y literally is negative x comma y. Okay? So an even function is, I'm going to take all my x's and I'm going to make them negative. Well, there's nothing to do here. This 3, 5 becomes negative 3, 5. And then the 7, negative 2 becomes negative 7, negative 2. Okay? That's what a reflection over the y-axis is. We change the x's to negative. We multiply all the x's by a negative 1. We leave the y's alone. So that's what I did. Okay? So 0, 0. Now I have negative 3, 5. So 1, 2, 3. 1, 2, 3, 4, 5. And then we have negative 7, negative 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So we complete the graph. So now notice how we have a mirror image over the y-axis. Okay. Odd function. An odd function is a reflection in the origin. And if we recall from the other days, a reflection in the origin is when you negate the x and we negate the y. We negate both. So, 0, 0, we don't do anything with. That negate them, still 0, 0. Okay, 3, 5 becomes negative 3, negative 5. And then 7, negative 2 becomes negative 7, positive 2. Okay. Remember, you multiply each by a negative 1. All right, so now I just got to plot those points. So 1, 2, 3, 1, 2, 3, 4, 5. And then negative 7, negative 2. So 1, 2, 3, 4, 5, 6, 7, 1, 2. So now when I connect these points, that is, what an odd function is. It's a reflection in the origin. Okay? So in other words, all of these points, if you take a straight edge, would line up. Okay? If we took a straight edge, they would all line up. I'm looking for something I can use as a straight edge. Oh, shoot my pen. See? So how those all line up, they go through the origin. They line up, they go through the origin. That's how you know you have a reflection in the origin. Okay. All right, describe the symmetry of an even graph and an odd graph. Well, we just did it. An even graph reflection over y-axis. Odd graph reflection in origin. Okay. All right. Now what we're going to do is we're going to talk about how we can do this algebraically. So let's look at some examples. Okay, we have these. We have what are called tests. We have an even test and we have an odd test. Okay, so doing these things algebraically now. So even, odd functions, algebraically. Okay, we have an even test. Okay, number one, we literally plug in negative x for x. So we swap out all the x's, we use parentheses, and we put in negative x's. Then we simplify. Okay. Number three is new equation same as the old. In other words, are they equal? Yes. Even. No. Not even. Okay? We don't say yes, even, if it no, odd. No, it doesn't work that way. It's either even or it's not even. That's it. All right, then we have an odd test. Okay? So our odd test, remember the 1, we plug in negative x for x and negative y for y. So we simplify, and we have that same question to ask. Okay. Is the new function same as the old? Are they equal? Yes. Odd. No. Not odd. Okay? So you always have to do both tests to know if it's an even function or an odd function. Okay? And remember, an odd function is origin, reflection in the origin. Reflect in origin. So that's your x, y, negative x, negative y. Well, I hope I got enough room on there. And then even function is reflect over y-axis, so xy, negative x, y. So that's why we replace those x's and why we replace both. Okay? Let's look at an example. Y equals 2x squared minus 3. So the question is this function an even function or an odd function? Okay, so there's our question. So we have to do both tests. Let's do the even test first. So we're going to do the even test first. So I'm going to take all my x's and I'm going to swap them out with a negative x. So y equals 2 parentheses squared minus 3. What goes inside the parentheses? That's right, a negative x. And now I clean it up. We simplify it. Well, negative x squared is positive. So this is saying y equals 2x squared minus 3. Now we have that question to ask. Is this equation the same as this equation? They're identical, so yes, even. Okay. Now let's look at the odd test. So now on the odd test, we replace both the x's and the y's. So negative y equals 2 parentheses squared minus 3. Oh, let me do this. There. Okay. And now I clean this up. So negative y is equal to 2x squared minus 3, right? Remember, negative x when you square it's positive. And now we don't say negative y because there's no negative in front of that y. We have to divide everything by negative 1. So when I divide everything by negative 1, I get y equals negative 2x squared plus 3. Is this equation the same as the original? No, not odd. That's it. That's how you do your tests. Let's do some wacky ones. All right, let's do another one. Y equals x cubed minus x. Okay, so let's do our even test. I'm going to slide this up a little bit. So we're going to do our even test. So remember, we're going to swap out all the x's with negative x's. So y equals parentheses cubed minus parentheses. Okay, so the even, we're going to swap out, put negative x's in. And now I have to clean this up. Y equals, well, negative x when you cube it is still negative. A negative times a negative times a negative is still negative. So negative x cubed. And here we have a negative times a negative is positive x. Is this the same as this? No, not even. Now we're going to do the odd test. So equals blank squared minus blank. Right. Remember, negative x for x, negative y for the y. So here we have our negative y. Here we have our negative x's. Ooh, this is a cube. That should be a cube. All right. So negative y equals, right, this is negative x cubed plus x. Remember, this says negative y. We're not done yet. So now we have to divide everything by a negative 1. So y equals x cubed minus x. Is this the same as the original? Yes, it is. So yes, odd. Okay? All right, let's do one more. Actually, we'll do two more. Now we're done. Oh, yeah, room I can squeeze it in right here. All right, so last one. Let's look at this. Y, actually we're doing two more. Y equals x squared plus 3x and so we're going to do our even test first. So y equals parentheses squared plus 3 with a parentheses. So negative x, negative x. All right, this is y equals x squared minus 3x. Is this the same as the original? No. Not even. Now we're going to do the odd test. Blank equals parentheses squared plus 3 with a parentheses. Okay? So negative y, and then I'm going to squeeze in my negative x's here. Okay? All right, so here we have x squared minus 3x, and this is equal to a negative y. When I divide by a negative 1, what happens to all my signs? That's right, they all change. So y equals negative x squared plus 3x. Remember, we divided by negative 1. Okay? Is this the same as the original? No, it's not. So not, no, not odd. There. So this is not even, or is it not? No, it's not even and it's not odd. That's okay. We have functions that are neither. Okay. Okay. All right. Let's do one last one. What if I had not a function, but a relation, but an Anybody remember what this equation is from last year in geometry? All right, that's a circle. You're looking at a circle right there. That's the equation for a circle. Let's see if this is even or odd. Let's do the even test first. So we have all right, so we have to swap out our x with a negative x. So we have x squared plus y squared equals 49. Isn't this exactly the same as this? So yes, even. All right, well, let's do the odd test. Remember, yeah, that's right, we're replacing both in the odd test. All right, negative x squared. And we have y squared. So that is definitely the same. All right. Functions will never be both. Okay. This is a relationship. It's an equation. It's not a function. Okay. So those have the potential to be both. So this one is definitely both. All right, folks. That's it for today.